Welcome back to part 2 of the video lesson for 11.4. Okay, at the bottom of page 7 there is a line for you to try to find the equation for. So go ahead and use the same steps that we did in the previous problem and find the equation of the line by finding the slope and the y-intercept, and then give the slope-intercept equation. Okay, make sure you pause the video and practice this problem, and then you can return to the video and watch me work it out. My first step is to look at the line on the graph and see where it crosses a point that where the graphs intersect. So I'm going to choose this point, and I'm going to choose this point. You could find others, like for instance you could choose this point, but I'm not going to do that. It doesn't matter. Just make sure you choose points that actually cross the line. Okay, so the point I circled in red is -4, 4, x equals -4, y equals 4. Okay, let's remind ourselves how we got that. Here's the point right here. We have to find the x value. X over here is 0. 1, 2, 3, 4 brings us directly underneath that point. So x is -4. And then we have to find the y value. Here y is 0. 1, 2, 3, 4 brings us horizontal to that line. So y is equal to 4. And then the point in blue is going to be 2, 0. So now we have 2 points, and from those 2 points we can find our slope. I will do it by counting, or I'll do it both ways. One way to do that is use the slope formula. So if we call x1 and x2, x1 and y1 to be this one, then x2 and y2 is here. So we are going to write y2 is 0 minus y1 is 4 over x2 is 2 minus x1, and be careful with your negative. So on top we get -4, and on bottom, since our negative minus a negative is the same thing as plus a positive, we get 6. But that's not our slope. Our slope has to be reduced. And you see that 2 is a common factor. 2 goes into 4 2 times, and 2 goes into 6 3 times. So our slope is -2/3. Okay, the other way you could find slope is you could start at this point, and you could say my rise is -1, 2, 3, 4. And my run is +1, 2, 3, 4, 5, 6. So using that method, I get my rise is -4, my run is +6, and then I reduce that, and I also get 2/3. So you get the same thing either way. Once we get the slope, we can write our slope-intercept equation as y equals -2/3 x, and then we don't know b yet, so we have to put b. Now we plug one of these points into our equation. I'm going to use this one because I like that 0 is easy to use. So we plug one of those points in, and we get y, which is 0, equals 2/3, or -2/3 I should say. X is 2 plus b. So when we multiply a whole number and a fraction, we change the fraction, or the whole number, to a fraction. And so we have, when we multiply two fractions, we multiply the numerators, and then we multiply the denominators. Okay, now if we add 4/3 to both sides, we find out that 4/3 is equal to b, or b equals 4/3. So now we can write our final equation, y equals negative 2/3 x plus 4/3. Okay, and that's the equation we are looking for. To check our answer, we're going to take this point and plug it in to this equation, and when we do that we get y is 4 equals negative 2/3. X is negative 4, but we're going to go ahead and change that to a fraction so that we can do our multiplication, and then plus 4/3. Okay, now we look at our first set of fractions, multiply our numerators, and we get positive 8 and 8/3 plus 4/3, they have common denominators, so all we have to do is add the 8 and the 4 numerators, and we get 12/3, and then when we reduce that, 3 goes into 12 4 times. So we get 4 equals 4, and we've shown that this equation is the equation for the line. Some people find the previous method a little confusing and consider the one I'm about to teach you an easier way to handle it. You can make your own decision about that, but basically you're given a slope and a random point, and you can write your equation immediately in a new form of equation, and that is called the point-slope form. The point-slope form says that a linear equation that passes through the point x1, y1 with a comma is y minus y1 equals m times x minus x1. For instance, look at the equation y minus 2 equals m times x plus 3. This is in point-slope form. It is the equation for a line, but instead of being y equals mx plus b, it's in a different form, and this form is called point-slope form. It means you can compare this form of the equation to this, and you can find out what m is and what the point is. So looking at this, you see y minus y1, y minus 2, so 2 is equal to y1, and then equals m equals 3/4, so m is 3/4, and then it says x minus x1. Well, here it says x plus 3, so that's not quite right. It needs to say x minus something, and that would be negative 3, because minus a negative is the same thing as plus a positive. So once we get it x minus negative 3, then that's the same thing as this, and we see that x1 corresponds to negative 3. So we can write the point to be negative 3 for x1, and 2, y minus 2, shows that y1 is 2, because y minus 2 corresponds to y minus y1. Alright, so to write an equation in slope-intercept form when you are given, and this should be slope, when you're given a slope and another random point, then you first write the point-slope form of the equation, y minus y1 equals mx minus x1, and then you solve for y so that you end up with y equals mx plus b. So y equals mx plus b is the slope-intercept form, and y minus y1 equals m times x minus x1 is the point-slope form. So you can get slope-intercept form from point-slope form by taking point-slope form and solving for y, and then you'll simplify and end up with y equals mx plus b. Let's work an example. In the middle of page 8, write the equation of the line with a slope of 2 that passes through the point negative 7, 4. First give the answer in point-slope form, then give the final answer in slope-intercept form. So point-slope form is y minus y1 equals m times x minus x1. So we need to know that m is 2, x1 is negative 7, and y1 is 4. So all we have to do is plug that in, y minus y1, which is 4, equals m, which is 2, times x minus x1, which is negative 7. So notice you have to be careful with your negatives. Now we know from our past experience that minus a negative is the same thing as plus a positive, so we can change both of those to pluses, and then we can write down our point-slope form, y minus 4 equals 2 times x plus 7. Now notice that if you hadn't simplified here by changing minus a negative to plus a positive, you would have had this equation, and it would have been wrong because it wouldn't have been simplified. So this is the simplified version of the point-slope form. To get the slope-intercept form, we're going to use green, and we are going to take our point-slope form of the equation, y minus 4 equals 2x plus 7, and solve for y. So first, we're going to simplify the right side by using the distributive property. Y minus 4 equals 2x plus 14. And then we're going to add 4 to both sides to get y by itself, so that finally we can write y equals 2x plus 18, and that is our slope-intercept form of the equation. This form, which is point-slope, and this form, which is slope-intercept, represent the same lines. They can be manipulated around and shown to be the same or the equivalent equations. So what I want you to do is work this problem and this problem. So pause the video, work these problems. You are to write the equation of the lines with the slope and the given point, and your final answer should be in slope-intercept form. You're going to do this first by writing the point-slope form. You have the slope and a point, so you can start with this step, and then solve for y so that you end up with this. Then come back and check your answer. Okay, I've worked out all of the first example, so your answer should be y equals negative 2x minus 8. And I've worked out most of the second one, but I want to demonstrate how to handle fractions and whole numbers. So I also want to point out, in this step you get x minus negative 2, and minus a negative becomes plus a positive. So when you multiply the 2/3 by a whole number 2, you change the 2 to be 2 over 1 so that you can multiply numerators and denominators. In this step, I've added 5 to both sides so that I can get y by itself, and here's where I'm at, but I'm not simplified yet because I have to combine these two terms. So I want to demonstrate how to combine 4/3 and the whole number 5. To add a fraction to a whole number, you change the whole number to a fraction, and now you have two fractions, and when you're adding fractions, they must have the same denominator. The least common denominator in this case is 3, So the first fraction already has a 3 in the denominator. We have to make the second fraction have a 3 in the denominator, and we're going to do that by multiplying the whole fraction by 1, because you don't change the value when you multiply by 1. But the form of 1 we're going to multiply by will help us have 3 in the denominator. So that will be 3 over 3. So that's going to be equal to 4/3 plus, and now when you multiply two fractions, after you've done all the reducing you can do, which in this case there is no reduction, you multiply the numerators and then you multiply the denominators. And actually, when you're changing to common denominators, you actually would not reduce in between, because you want your end result to have the denominator of 3. Okay, let's look at this step. We have two fractions being added together. They have the same denominators, so all we do is add the numerators and keep the same denominator. And so that is the result that we are looking for, that 4/3 plus 5 equals 19/3. So when we go back up to look at our equation, we combine 4/3 and 5 and we get 19/3. So our final equation, which I'll write in red down here, y equals 2/3 x plus 19/3. And that's your slope-intercept form, y equals mx plus b, where m is your slope, 2/3, and b is the place it crosses. It's the value of y when it crosses the y-axis, which is 19/3. So if you look at the bottom of page 8, we also take it one step further. The point-slope form is helpful if you are given 2 points on a line and told to find the equation. So I'm going to get rid of some of this stuff to clear up so that we can read. Step 1, you find the slope using the formula for slope. M equals y2 minus y1 over x2 minus x1. Just keep in mind that whenever you're given 2 points, you can always find the slope. Once you have the slope, then you have a slope and you have a point. You actually have 2 points, so you can plug one of the points into the point-slope form of the equation, and you can solve for the slope-intercept form of the equation just like we've been doing. Here are 2 problems we're going to work. We're going to use the slope formula in the first, and we are going to just count in the second. So in the first we have 2 points. Let's go ahead and plot them. You don't have to do this. In other words, if it just wants the equation, you don't even have to plot it, and I'll show you how to do that in the actually in this one. So we're going to use the slope formula, which is m equals y2 minus y1 over x2 minus x1. So we have, you can do x1, y1, x2, y2. It doesn't really matter which point you make x1, y1 or x2, y1. You just have to be consistent. So I've made it this way. That means y2 is 5, y1 is 4, over x2 is -2, and x1 is 3. So 5 minus 4 is 1, -2 minus 3 is -5. So we have -1/5, and I've made my denominator the negative number. Okay, so we are to write an equation using, we're going to use the point-slope formula, and so I'll do that in green. The point-slope formula is y minus y1 equals m times x minus x1. And since we found m is -1/5, and we can use either of these 2 points. Since I've called this point x1, y1, I'll use that. So we have y minus, and then y1 is 4, equals m, which we already wrote, times x minus, and then x1 is 3. So now I work to simplify that. I'll just keep all this here while I distribute. And then negative 1/5 times 3 is going to be a positive number, and I'm changing my whole number to 3 over 1. So I have y minus 4 is negative 1/5 x plus, multiply the numerators, multiply the denominators, and then I add to both sides the number 4. So when I add 4 to this side, I get y, and when I add 4 to this side, I get 4, and I'm going to put it 4 over 1 because I'm going to combine these two fractions. So let's look at the right side. We have negative 1/5 x plus 3/5 plus 4 over 1. Now, I'm going to combine like terms. There's only this 1/5 x term, but 3/5 and 4 over 1 are like terms, so they need the same denominator, because in order to add fractions, I have to have the same denominator. So I multiply 4 over 1 by 5 over 5, and that way I'll make both fractions have 5 as a denominator. Let's rewrite that equation. Y equals negative 1/5 x plus 3/5 plus, and then 4 times 5 is 20, 1 times 5 is 5. Now I have two fractions of the same denominator, so I can just add their numerators and leave the denominator the same. And that gives me y equals negative 1/5 x plus 23/5. Y equals mx plus b. So now I have it in slope-intercept form. The problem does not ask us to plot it, but let's go ahead and plot it. Now, since my y-intercept is 23/5, I'm not going to plot that. That's too hard to plot. So I'm going to go back to my original points. Since I have 2 points, I can simply plot those points and draw a line between them. So for 3, 4, x equals 3. So we go from 0, 0 and count 1, 2, 3, and y equals 4. We count up since it's positive, and that's the point we want to plot. So I'll do that in red. Well, let's see if I can get better on it. It's so hard to do that with this pen. Well, that's about the point, and now I look for negative 2 and 5. X equals negative 2. And y equals 5, and then I plot that point there. Now I have 2 points. All I have to do is draw a line between them, which you can do a lot better job with your graphing tool. But there you have a perfect line that passes through 2 points. Let's look at example B. In this case, I'm just going to go ahead and plot the points and determine my slope from the graph, just so I can demonstrate how to do that. So we again go to 0, 0 and count over for the first point. X equals 3, y equals 5. Plot that point. And then for the next point, x equals 3, y equals negative 1. We're going to plot that point. Now we see that we have a vertical line, and we could have just looked at these 2 points and noticed that x was the same, and when x is the same, you have a vertical line. So when you have a vertical line, you have the slope is non-existent, so you simply write that x equals 3. Because the slope is undefined, that's the way to say that. And when the slope is undefined, you have x equals a number, and obviously you can see that that number is 3, or you can look at the graph and count over and see that x is 3 everywhere on that graph. So you try on page 819, number 6A. Now we're going to talk about the standard form. We've learned the slope-intercept form, y equals mx plus b. We've learned the point-slope form, y minus y1 equals m times x minus x1. Now we're going to look at the standard form, which is a number times x plus a number times y equals a number. So you have ax plus by equals c. And a and b are not both 0 in this case. So to rewrite the equation y equals 3x plus 2 in standard form, we need our x term and our y term on the same side of the equation. So let's subtract 3x from both sides, and we get y minus 3x equals 2. So now we have our x and y term on the same side of the equation, but we need it in the form something times x plus something times y equals something. So we are going to move the negative 3x in front plus y equals 2. Now we have it as ax plus by equals c, where a is negative 3. You could also rewrite this by multiplying everything by negative 1, and that gets rid of the negative 3 in front. So if we multiply everything by negative 1, then we get negative 3x times negative 1 is 3x, y times negative 1 is negative y, and 2 times negative 1 is negative 2. So right now we can settle for this form of the equation, negative 3x plus y equals 2, because it hasn't told us that a has to be positive. But later on we are going to write standard equations in the form where the initial coefficient is a positive number. Okay, that's all I'm going to say right now about standard form. C, writing equations of parallel or perpendicular lines. This is very important, so you may want to pause it and take a breather, take about 10 deep breaths, and then come back to shift gears a little bit. Parallel lines have the same slope, and that is an important clue when we're dealing with finding lines that are parallel. So write the equation of the line in slope-intercept form, that in which you have a line going through the point negative 4, 5 that is parallel to the point 2x plus 3y equals 6. Okay, let's do this. We need to find the slope of 2x plus 3y equals 6, because we know that parallel lines have the same slope, so the parallel line that we're finding has the same slope as 2x plus 3y equals 6. So we need to get y by itself. We know how to do this already because we've been practicing this. Let's subtract 2x from both sides, and we get 3y equals negative 2x plus 6. But we need y by itself to get it in slope-intercept form, so we're dividing everything by 3, and 6 divided by 3 is 2. So there is the slope-intercept form of this equation, and we know from that our slope is going to be 2/3, and that's what we've been looking for. So m slope for this line is negative 2/3. If I said positive earlier, I meant negative. Okay, now we can forget this line. We can forget all of this. What we are going to do is find a line that goes through the point negative 4, 5 and has the slope negative 2/3. So you have a point and a slope. Use your point-slope formula to find this line in slope-intercept form. So pause the video and go ahead and do that. Your answer should have been y equals negative 2/3 x plus 7/3, and if you want to see this worked out, you need to go to the class notes keys for 11.3-11.4 and look on page 9. Okay, I've just cleared up the earlier stuff to make room for our next work, but let me go ahead and replace the word same up here. Now, perpendicular lines, if you look right here, perpendicular lines have slopes whose product is -1. Now, don't let that throw you. All that means is that for perpendicular lines, the slopes are reciprocals of each other. So we are to write the equation of the line in slope-intercept form that satisfies the following conditions. We have the same point and we have the same standard form of the line that we did in the above problem. So that means we already know that the slope-intercept version of this line is y equals -2/3 x plus 2. Okay, from this we know, as we learned above, that the slope of this line is -2/3 x. So let's go ahead and write that down again. I mean, not -2/3 x. And that brings me to a very important point. When you type in slope in your homework or on your test, it would not be -2/3 x. It would not have the x in it. The slope is simply -2/3, so be sure not to put that x there also. Okay, now that we've figured out what the slope is, which we had actually done earlier, we can get rid of this and ignore this line here, because we're trying to come up with a line that is in slope-intercept form that is perpendicular to the line we started with. And we know that that line is going to have a slope not of -2/3, but of the negative reciprocal. So you want to make sure it's the negative reciprocal of the slope of the line you're starting with. So the reciprocal of -2/3 is -3/2. The negative of -3/2 is +3/2. So our new slope is +3/2, and we can ignore what we had written before. Our new line has a slope of 3/2, and it goes through the point -4, 5. So we have a point and the slope. We can use the point-slope form of the equation y minus y1 equals m times x minus x1. So y1 is 5. Our new slope is 3/2 x minus, and then we're going to use -4, which minus -4 is plus +4. So now we have to change it to slope-intercept form instead of point-slope form. Sorry if I confused those earlier. We want y by itself, but first we're going to simplify the right. We have 3/2 x plus 3/2 times 4/1 is 12/2. And 12/2 reduces to 6. Hallelujah, we have a whole number. We don't have to mess with fractions. Now let's move 5 over by adding 5 to both sides, and we have y equals 3/2 x plus 6 plus 5. So our final equation is going to be y equals 3/2 x plus 11. I'm going to move this up to make sure you can see it. I'm going to get rid of these. That's not going to do it. Just ignore those words there. I can get rid of this one. Okay, so our final equation is y equals 3/2 x plus 11. Now it is very important for you to pause the video, turn to page 821 in your textbook, and work problems 7A and B before we get on to the next concept. Okay, welcome back. You have a word problem. A membership to Judy's Gym costs $99 plus $41 per month. X is the number of months, Y is the cost, and so you are to write an equation in the form of y equals mx plus b. So if y is the cost, we know that the total cost is going to be $41 per month times the number of months, which we're told is x, and I don't know why I just wrote m. Let me erase that. So 41 times x plus, and then we have the number $99. So your initial fee is going to be $99, and if you have to pay a month up front, you're doing 41 times 1 month plus $99, or $140. Okay, so what if you're going to join for 5 months? Then you would say y equals 41 times the number of months is 5 plus 99, and if you work that out, you'll see that equals $304. So 5 months costs $304. So how much do you think the first year's membership costs? Pause the video and work that out, and then compare your answer. So the above example shows how you look at fixed and variable cost. Fixed cost is the part of the cost that doesn't change. Variable cost is the part that changes. When you have an equation y equals mx plus b, the fixed cost is b, the variable cost is m, and the total cost is y. The number of items we're talking about is x. So above, the number of months was x, the variable cost was m, which was 41, the fixed cost was $99, and the total cost was what you solve for when you use the equation y equals mx plus b. So in this example, it costs $2,000 to purchase the copier. Each copier costs 2 cents to make. So what is the fixed cost, the variable cost, the cost equation? What will it cost to produce 10,000 copies, and how many copies will be produced if the total cost is $2,600? So go ahead and try to work that, and then come back for the solutions. So the fixed cost is $2,000, the variable cost is 2 cents, the cost equation is y equals 0.02x plus 2,000. So we use that cost equation to figure out the cost it will be to produce 10,000 copies. Y equals 0.02 times the number of copies plus the initial cost. So when we calculate that, notice that 0.02, we can move the decimal of the original 0.02 to the right 2 places by moving the decimal of the 10,000 to the left 2 places, and we get y equals 2 times, when we move it to the left 2 places, we're left with 100 plus 2,000. So that's 200 plus 2,000, which is 2,200. So it'll cost $2,200 to make 10,000 copies. Okay, the last one is the trickiest. How many copies will be produced if the total cost is $2,600? So we look at our cost equation. Y is the total cost, so we plug in $2,600 for Y. And according to our equation, that's equal to 0.202 times x, which we don't know, plus 2,000. So now all we have to do is solve for x. So let's subtract 2,000 from both sides. We get 600 equals 0.02x. And then we divide both sides by 0.02 equals x. You can do that with your calculator, or you can remember from math days gone by that when you move the decimal 2 places to the right in the denominator for division, you move the decimals 2 places to the right in your numerator. So you would get 600 and then 2 more zeros over, and then your denominator, when you move the decimal 2 places to the right, you get 2. So 6 divided by 2 is 3. Write down all of those zeros and you get 30,000 equals x. So the number of copies you could make is 30,000 copies. And that is the end, except you should try it on page 822, numbers 8a, b, and c. And that brings us to the end of section 11.4 for chapter 11.